Welcome to Summarize Science. What if an AI could pass an eye exam without ever looking at the chart? It sounds impossible, but a new paper reveals that many of our most advanced AI models are doing something similar on tests designed to measure their visual understanding. These models, called multimodal large language models or MLLMs, are supposed to understand both text and images. We test them using benchmarks, which are like standardized tests for AI. However, the researchers found that these models often don't need the image to get the right answer. They just exploit biases and patterns in the questions. For example, in a counting task, if the answer is almost always 2 or 3, the model learns to just guess that without actually counting objects in the picture. Or in a task about object positions, certain objects like keyboard might disproportionately be the correct answer. This is a huge problem because it creates an illusion of progress, where we think AI is getting better at seeing, but it's really just getting better at finding shortcuts in the tests. To fix this, the researchers propose a bold new strategy for benchmark designers. They should intentionally try to game their own tests before releasing them. The core idea is, if a benchmark can be cheated, it will be. They call their method the test set stress test, or TST. It works by taking an AI test, hiding all the images, and then training a special diagnostic AI only on the text parts of the questions and answers. The score of this vision-blind diagnostic model reveals exactly how exploitable the test is. When they applied this stress test to 4 major AI benchmarks, they found pervasive shortcuts. For 2 of them, the diagnostic model's score jumped by over 30 points just by learning the patterns in the text with no vision at all. Once the most biased questions are identified, they use a process called iterative bias pruning. Instead of removing all flawed questions at once, they carefully remove the worst offenders in small batches and then rerun the stress test. This ensures they aren't accidentally creating new, different biases in the process. As a case study, they created a new DiBiase version of a benchmark called VSI Bench. The results were clear. On the new, tougher version, the gap between an AI with vision and one without vision grew significantly wider. This proves their new benchmark forces the AI to actually rely on its eyes to solve the problems. So, let's recap the key points. First, many of our current AI vision tests are flawed, allowing models to get high scores by exploiting non-visual shortcuts. Second, the researchers developed a powerful stress test to proactively find and quantify these vulnerabilities by training a diagnostic model on the test's text alone. And third, by using these insights to prune the most biased questions, they can create much more robust and reliable benchmarks. This work is crucial because it pushes us toward building AI that has genuine visual intelligence, not just clever test-taking skills. In the future, this will help ensure that AI systems in critical areas, like self-driving cars or medical diagnostics, are making decisions based on what they actually see. Thanks for watching Summarize Science.